जो यहाँ से हो रहा है आई थिंक अभी हो रहा है. Hello everyone. Good evening. Welcome to our today's discussion. Apologies for a slight delay here. We're having but I think we're good to proceed now. So let's get started. Okay, cool. So today, guys, we are talking about another use case of machine learning. So in the previous discussion, we talked about how Netflix leverages the benefit of data in terms of their respective use cases and the problem statement they're trying to solve using the data. So now today we will be talking about Uber. So how Uber is actually leveraging data and what kind of platform they have built up, and how exactly, what are the problem statements basically Uber is looking at to solve in data science. So that is what we are trying to understand in today's discussion. So that's going to be my agenda for today. Right. So that's pretty much what I'm going to talk about. But before that, let me introduce myself. You know, my name is Arpit Jain, and the only reason I'm here because data science is my passion and I really like sharing my expertise with people. In overall, I have close to 10 years of industrial experience in data science across different profiles and portfolios and the roles. Along with this, I also like talking to students. So I'm a public speaker. So I talk to students regarding their career, job, placement. So anything in general also I'm more than happy to discuss. So that's pretty much a brief introduction about myself. And while being into data science, I must say that I have been working into the different areas of data science which you can look at. So which is prominently starting from statistics till the end of machine learning, deep learning, and advanced deployment structures as well. So that's a brief about myself. Going forward, agenda for the day, it's going to be talking about how ML use case are structured on Uber. So we will be talking about Uber as a platform and how Uber is now using the different things in terms of understanding my parts in terms of the data part here. So we will be trying to understand how machine learning is getting used on Uber platform and what are the different problem statements which Uber is trying to solve from the data what we have. So that's pretty much what the agenda for today would be. Before starting, as always, a quote for you for the day: data is the new science, as I've told you. So whatever you can think around you is basically comprising of some of the other information, right? And that information is what we call as data. And that is what the new science is. You're trying to hold your answers, you're trying to get your respective answers to your problem statement depending on the data which you have. And that is going to solve the problems around you. So data is the new science, as I've told you. And the big data, where I talk about the enormous amount of data, which is trying to uphold the different problem statements, is going to give me the answer for different problem statements. So data is a new science and big data holds the answers, what you're looking at in your business. So with this, let's start a quick recap of what we talked about machine learning in general. So we talked about how machine learning is going to play a role in terms of my data science problems, right? So a quick recap, we've already studied these few things, but I'm going to quick recap. And then we will move towards how Uber is leveraging this machine learning strategies to help the business front. So we will be discussing about the different problem statements and we will try to analyze how this has actually solved major of the business problems around, and eventually with the help of the data which Uber is trying to collect, how it is able to do the business in a much strategical way, right? A quick recap. So machine learning, as I've told you, this includes a section of AI, and deep learning is part of my machine learning. So three fancy words here. We talk about artificial intelligence, we talk about machine learning, and we talk about deep learning. So three fancy words here. So artificial intelligence, as I told you, it's nothing but further subdivided into two broad sections. First, where I talk about a specific problem statement to be solved, one problem statement at a time. That is nothing but called as weak AI or narrow AI or weak AI. And the second, we talk about robotics, we talk about mimicking my human brain. That's where strong AI comes into picture, or we also call them as AGI, artificial general intelligence, and that is a field of robotics. But our machine learning is falling under the category of weak AI, guys. Okay, so that's where ML comes into picture. So with ML, we are talking about solving one business problem at a time. When I say one business problem statement, I say finding out the price of a house or predicting whether the person is having a cancer or not. So I'm not doing anything else apart from that. I'm only doing that one single job out of my analysis. That's where the machine learning comes into picture. And that is pretty much where the weak AI comes into the part. So weak AI, ML, that's where ML is part of. And under ML, ML is nothing but a set of algorithms, a set of different protocols or rules through which I am trying to solve a business problem, set of protocols or set of rules. And that is where deep learning comes into picture. And we say deep learning is again set of few those rules in part of machine learning, the specific set of rules, again designed to solve certain business problems. So here, objective is to learn the data and give the meaningful business outcome. So ultimately, with the help of this learning, what machine learning is having, I'm trying to make the machine learn whatever data I have. So learn the data. So the input to this learning mechanism is basically a data, right? So a data again could rather be a CSV file or an Excel file or whatever the different source I have. So any piece of information is my data. So whatever data I have, I'm trying to learn, make the machine learn the data which I have. And from this data, trying to get some meaningful business outcomes, how the data is having some set of interaction effect internally. And machine learning includes my pattern recognition. So when I say learning of my data, I basically say try and understand some hidden pattern available inside my data. Right? And this includes the ability to recognize the patterns in my data. So I'm trying to understand what exactly I have within this data structure for this to get my pattern identified for the learning process. And the pattern should be trained to show the output in a desirable manner. So ultimately, when I say this training process or the learning process, this learning is nothing but finding out this pattern, and based on this pattern now get trained or learn to show the output in the respective desirable manner. Similar example, when you go to a doctor, same thing we have studied. So if I have symptom 1, 2, 3, 4, that correlates to a disease, right? So I have a pattern between that. So if I have these 3, 4, 5 symptoms, or I have some ups and downs in my blood reports, that correlates to one of the other disease, right? So that's just something what the pattern means. Again, it's some bit of data. And that is exactly Now the machine is getting trained on, if it sees similar patterns, it should know that yes, this correlates ultimately to this disease. So likewise, there could be multiple business problems. But the end objective is, based on this learning what I'm having here, the machine is able to identify what exactly the pointers should be here. So this is what we are trying to understand from this machine learning part. Cool. So this is what do we have from the quick recap of my machine learning. So moving forward, now let's try to understand how Uber is leveraging the data science part here. So how Uber is able to solve some of the very critical problem statements and offer you very fancy, data pointers on your application with the help or the backing of the data which it handles in the background. So first thing, have you seen this price search on Uber? One of the very crucial and the good business model, not only from Uber, other competitors as well, but where they're able to capture the high peak hours, and based on this high peak hours, they are able to make a price surge in their service offerings. So let's try to understand, what do we mean by this handling of my peak hours? What is the definition of my peak hours? So for Uber, the business is the cab rides, right? So how does Uber know for which location there is a peak hour? If you are in a metro city, for example, suppose if you are in a metro city, yes, we have peak hours in terms of office hours. So on weekday, we say that yes, office hours may be morning, say 7 a.m. starting or 8 a.m. starting till 10 a.m. is my peak hour, and evening 5 p.m. till 7 p.m. is my peak hour. Can we say that? Right? So office hours generally on a weekday in the metro cities are considered to be as my peak hours, because a lot of people might be looking to book the cab during that hours. So this can be considered as a peak hour. Likewise, on a weekend, we might not see this same morning hour trend, but we might see a surge between 8 p.m. to 11 p.m. So can you see a difference in the dynamic nature of my hours? So again, it is very much dynamic. So what I'm saying, it's still a static information. So this is by a general trend. What if, suppose it rains someday, it is raining very heavily, right? And when it is raining very heavily, you automatically see again an increase in the demand of my cabs, because maybe the people who are traveling on two-wheelers, they might still want to go with a cab. Might happen. Likewise, I might still look at a few of the things where, in terms of not only weekday and the weekend trends, we also look at the day hours. So maybe even during the day, suppose between 2 p.m. to 4 p.m., I might see a surge near, malls, shopping malls. So maybe near shopping malls, I could see a surge or maybe more demand between 2 p.m. to 4 p.m. So how does Uber gets to know at which location, and I'm only talking about a metro city right now, this hours might not be valid for a second tier city or a third tier city, where I still have an Uber pricing model. So these all handling of my information is pretty much backed by the data which I have in the background, right? So Uber continuously analyzes the pattern of its usages, and accordingly it understands and it knows that yes, there is a particular trend during this hour of a day in a particular location where yes, I'm seeing a huge demand. So there are two possible ways in which this can be handled. One, it can look for a prediction. Like for example, I know for the past 3-4 months or whatever time period, evening 5 p.m. to 6 to 7 p.m. on a weekday in a metro city, suppose in NCR, is expected to have high demands of my cab. So yes, my prediction model knows that based on this history, I'm going to have a huge demand of my cab. So yes, there is a predicted model which is running in the background. Also, it works on a real-time basis. So apart from a prediction model, we also say that now we have a real-time analysis. So it works in both the ways, where it tries to handle the peak hours and accordingly it adjusts its price of the services. And that is where Uber is handling the peak hours. How? First, identification of my peak hours respective to each geographical locations. And then based on this identification of my peak hours, I'm trying to do a real-time price search to leverage or to handle the respective huge high demands. Another very interesting use case from Uber you can think about is matching fares. So the moment you book any service, the moment you try to book any cab on Uber, you always get an estimate, right? So before even booking the cab, you'll always get an estimate beforehand. So how does that work even? So even in that case, when I have this respective different services coming from the different users, so even in that case, Uber still gives you an estimated fare similar to what other competitors are also providing. Again, pretty much we have a predictive model as well as real-time analysis coming into picture. So Uber as a platform also leverages the data which we have right now, and based on this data, it is trying to give you an estimated fare for any service, for any ride which you book, comparable to its competitors. It is not going to give you a price which is completely not relatable with other competitors. It is going to give you a price which is still comparable to other vendors. Also, like to like rides always analyzes my user profile. Like to like rides. You understand? We have the rating system in the Uber. So we always talk about driver rating, but we also have user rating. So like the way you rate a driver also rates you, right? And the moment we have this user rating, so you also have a rating on Uber, your star ratings. And yes, your star ratings is also a data which Uber analyzes. Yes, if you are towards the higher side of your rating, you are expected to get premium rides. You are expected to get an upgrade in your rides. The moment your rating falls, according to your ridership, a ride is getting allocated to you. So like to like rides depending on my user profile, that is again what Uber tries to handle in terms of your data analysis. Very, very interesting problem statement, very interesting thing. So it is going to only suggest, it is only going to only allocate the resources which is similar to your profile. And how again your profile is getting built up? You have your respective demographic informations already when you sign up your account. And there is a trend, there is a usage patterns of your booking. So now Uber knows that, okay, every morning 8 a.m. you take an Uber bike to your office. And evening 6 p.m. you take maybe a Uber Micro or Uber Mini while coming back home. And accordingly your rating profiles. So Uber knows what exactly your driving patterns are, what exactly your ridership is, and accordingly Uber analyzes the profile and allocate the like to like rides for your upcoming next bookings. Very interesting problem statement. And not only this, more importantly, in Uber, they always come up with something called as new products. We'll try to understand this new products. And this new products is where we have a complete data backed decisions. Very importantly, we talk about Uber Pool. There are multiple benefits involved in Uber Pool. We will be seeing that also. So Uber came up with a very fantastic idea of Uber Pool. So what exactly Uber Pool is? I think many of us have already used this. So we talk about like to like ridership. And obviously in COVID times, this has gone down, but this was one of the very fantastic problem statement, a very fantastic product which Uber launched. And we talk about similar ridership. Suppose you want to travel from place A to place B, okay, and the fare which you are seeing is approximately say 300 INR, and you want to still travel to that place but not want to pay a similar amount. You want to pay lesser than that with similar features. Yes, for that reason, there are other benefits also. Now, a product called as Uber Pool, what it does, it tries to find out other users also who are trying to travel from similar to similar location, from position A plus minus 2 kilometers to position B, place B plus minus 2 kilometers on the similar time. That's where Uber comes into picture. So what it does in this case, Uber tries to match the multiple bookings from place A to place B. Place A, place B, we have a flexibility of plus minus 2 kilometers here. Similar time, and they give an option to travel together. So now a price of 300 INR gets split for multiple users. You might end up paying 150 bucks or 100 bucks for that with the similar features. That's where Uber Pool comes into picture. Obviously, it does help in reducing my traffic. Multiple benefits, I could say cost saving, traffic. So more cars, more rides, more traffic. Obviously, it does help in having the better traffic. Obviously, if we have lesser traffic, less pollution, so eco-friendly. So ultimately, this Uber Pool was such a fantastic idea where based on the real-time data analysis, so how exactly Uber knows that which all users trying to travel from which to which location, and at what time. There are so many data points here. So many data points. And yes, Uber does analyzes all of these data points in the background. And at the end of this analysis, the users are mapped together. They are clubbed together as one pool, and they are being offered this ride of Uber pool. A classic case of customer segmentation, not a customer segmentation, but rather identification. And in this case, similar traits, similar journey. And again, when I say trait here, I do not mean the age and the customer demographics, because this is completely irrelevant here. I'm still going to talk about the rides where my users are going to travel, time X from position A to position B, plus minus 2-3 kilometers. That's where I'm going to look at. And that is where Uber pool concepts came into picture. Very fantastic concept. And again, not only this, we also talk about Uber ride, we talk about Uber auto, we talk about Uber luxury. So all of these ridership options, what Uber provides. Uber ride, two-wheelers, very friendly for people who are trying to still travel but willing to pay less. Uber ride does help to save a lot of money, and it gives you an option. Instead of traveling in a cab, you can rather take a bike, two-wheeler, and still save and still travel from one place to another. Yes, you will have to, adjust to the ridership in that case, but yes, it does have an option of Uber ride, Uber auto, Uber luxury for ultra luxury cars, maybe a premium cars. That's what will come here. And if you want to still travel from one place to another, but you want to use some luxury car, you can probably book Uber luxury. So all of this is pretty much what an option of Uber. How exactly Uber knows? So do you think Uber ride and Uber auto is available in other continents? So when I say India, yes, you might see Uber auto. Do you think Uber auto is present in the US or any other countries? Might be not. They might have something else. So how exactly Uber knows that yes, there is an option of ridership in terms of auto in India? That is completely what it's backed by the data. Based on the patterns, based on the analysis, based on the available information, yes, Uber knows. Uber auto is one of the methods, one of the ridership which is popular in India. Again, a pure problem statement where a data comes into picture, and based on this analysis, a strategic decision of offering service in terms of Uber auto for Indian market. Yes, that is a very classic example of data-backed decisions. Certain key insights I would like to still talk about from the Uber part. So let's try to understand how the business of Uber is broadly divided into multiple subsections. So first thing first, let's talk about the key partners. When I say the key partners for Uber, who are my key partners? We talk about the drivers. Without the drivers, Uber will never flourish. The drivers are the key partner for Uber in this case. Apart from driver, we talk about the technology partners. So there are a lot of technology services which are still backed in terms of Uber. So we talk about the API providers, some of the database services, others. There are a lot of investors. So all are my key partners of Uber. And when I talk about the customer relationships, here we talk about the ratings and the feedback system. So for each of your ride, the way you are giving a feedback for your driver, the driver is also giving a feedback to your ridership. A very important entry point to optimize the ridership experience of all the users. It is not only for me as a person who is booking the ride, but it is also for the drivers, because drivers are the key partners for Uber as a platform. Then we talk about the customer support. Very important. So the moment you face any issue, the place where you go to is your customer support. And if your customer support is not that great, again, you're going to face the problems in a long-term business. So how does a customer support gets optimized? Again, we have a lot of information, the feedback mechanism, the data, the recordings, where we try to optimize the customer support system. Self-service, highly automated meetings with the regulators, again, are my customer relationships. The key resources in terms of Uber, we talk about the technology team. So again, the entire business where we have in Uber, it talks about the different team, the technology team who are working together to bring up the system running. So we talk about the interface, we talk about the UI, we talk about the application which you are using. So a lot of technology involved in the background. So we have a technology team in Uber which takes care of the end-to-end running of my system. And for this also we have the AI ML analytics expertise team, as I was telling about in Uber. So they always look towards having the optimization of my data. And with the help of data, with the help of this analytics AI ML team, Uber tries to leverage the data back decisions. And that is the only reason why they are able to solve these practical business problems, which we were talking about in our examples. And Uber stands aside from these. Network effect. So we have the drivers and the passengers. We talk about the brand name and the assets. We talk about the data and the algorithms. So what are certain key activities what Uber looks at in terms of creating its own business? So we talk about adding more drivers, at the same time also adding more riders. So how Uber thinks about expanding the business, right? So without drivers, I cannot cater more rides. And if there's no more riders, then I don't need more drivers. So adding more drivers and at the same time adding more riders, they both are equally important activities. Expanding to new cities is very important. So Uber does try to look at the prospects of new cities, again backed by data. So they try to understand how exactly an Uber business model will be working if it is getting launched in a particular city. So most of the metro cities in a country is nowadays having a facility of Uber or the similar cab platforms. But moving to the tier 2 and the tier 3 cities, that's where they try to look at the ROI of the benefits, like what exactly the ridership would be providing. Adding new ride options, very important. So this new ride options, as we have talked about Uber Pool, we talked about Uber Ride, we talked about Uber Auto, which might be prominently flourishing around your region. You might not see similar things in other regions. Uber pickups. So there are a lot of other services, other ridership options which is provided by Uber respective to a particular region. So how does Uber know that where to add which particular ridership options? Again, a completely data-backed decision. Adding new features and offer for help and support. Again, certain key activities where Uber tries to solve the business problem. And then from the analytics perspective, they always talk about the customer segments, very important. So like to like ridership, as I was talking about. So customer segments, that is where it looks at people who don't own a car, right? So people who don't even own a car also are very, very, very important. So people, if they don't own a car, they need to have some sort of understanding in this place. So again, Uber comes into picture, identifying the right set of people, which does help segmenting my right set of people. People who do not need an affordable, who need an affordable ride like Uber Pool, or people who need a premium ride, so Uber Luxury. People who need a quick ride, maybe Uber ride options like two-wheelers. People looking for a convenient cab booking, people who can't drive on their own, chauffeur-driven cars. So a lot of different segments, different set of products which Uber tries to look at, and ultimately based on this, it tries to identify how exactly Uber should be looking at solving the different business problems. The channels, different channels, what we talk about in Uber, so mobile app, the social media, the word of mouth, online advertising, offline advertising, again, a very big marketplace to invest on. So mobile application, social media, the word of mouth, online advertising. So Uber knows which customer has the highest probability to take up the ride, and accordingly, the advertising would be targeting these right set of customers. Offline advertising, finding out the right places to flag up the billboards or to flag up certain pamphlets. So again, multiple channel partners. So value propositions, we talk about how the value propositions work for passengers. We talk about on-demand booking, real-time tracking, accurate ETAs, cashless rides, upfront pricing, multiple ride options. And this all options are pretty much you are seeing on your day-to-day ridership experience. Accurate ETAs, right? So even before you take up your ride, it is able to give you the accurate estimated time of your arrival. And based on this, analyzing the traffic around you from the place to place you're trying to move, giving you the upfront pricing as well. Pretty much everything here where you could see the usage of my data analysis. For drivers, we talk about the work flexibility, we talk about the better income, we talk about the lower idle time, the training sessions, the better trip allocations. Because for Uber, passengers as well as drivers, they both are equally important. So giving better work flexibility, the better income, the lower idle time, all of this becomes my crucial part for the drivers. Cost structures, salaries to employees, yes. Driver payments, technology development, R&D, marketing, legal activities, my cost structures, and then likewise the revenue streams, where we talk about the surge pricing, the premium rides, the cancellation fees, leasing fleet to drivers. All of this pretty much become important business aspects for Uber. So this prominently gives you a fair idea how Uber takes care of Uber business in general. Now we'll try to see how this is solving some of the crucial business problems, guys. Let's try to see, by doing this data-backed analysis system, how Uber is solving some very crucial business problems. So here, if you could see, Uber is now able to help. So when I say Uber Pool, right? So Uber Pool does help in reducing the traffic, as you can see here. And with this, Uber actually reduce the traffic significantly, right? So you can see here how Uber is trying to separate the different ridership options. So with this, if you can see here, my separate trips part, can you see the red lines here, the traffic, and the yellows for a particular location? So if you are able to see, the moment we have the separate trips, that means more cars on road. And in the Uber pool trips, can you see? I'm reducing the number of cars on the road, and the traffic is probably towards the bluer shades. Can you see this bluer shades? The low part of my traffic. So everywhere you can see the blue shades. So there's no red, there's no yellow in my traffic. So Uber reduces the traffic, Uber pool reduces the traffic significantly, solving a very crucial business problem for me. I have a question from Raj here. What if we are asked to pick out the 3 most important data to look out? What it could be? So a good question, Raj. So it is very subjective to what business problem you're trying to solve, first of all. Okay. So for example, suppose I'm saying that I'm on Uber and I'm trying to solve any business problem, and I'm asked to say that, okay, you have freedom to choose 3 different data sources, and then you have to solve this problem statement. So it is very subjective to problem statement. For example, suppose I say I am trying to introduce Uber pool as a service, right? So for this Uber pool as a service, what data points I would be looking at? For this Uber pool as a service, do you think I need information of Indian cricket teams batting and the bowling performance data for the last 1 year? Do you think I need that data? No. So subjective to this Uber pool problem statement, I might be looking at what is the prospect of rides in different locations, what are my timing information, maybe some user demographics, maybe I look at the ridership pricing search. So data around the problem statements. So it is not always 3 most important data, 3 most important data according to my problem statement. And it is very subjective. And again, most important is very relevant word, right? When I say most important, you are still kind of foreseeing that this data, what you're looking at, might be important, but this might not be important once you start analyzing. So we never know in the very beginning itself that this is going to be my most important data. We may assume that yes, this might be one of the important data, but we cannot be 100% sure. So we always try to capture the maximum information. We try to then start our analysis process, and with the help of analysis, we try to come up with something which is more relevant to my business problem. So that's what the right process is. I hope that answers your questions, Raj. Okay, coming back. So again, a marketplace forecasting in the California Bay Area allows to direct drivers to high demand areas. So with the prediction process, we know that this area of a particular location is expected to have the higher traffic during certain time of the day. Likewise, here I could see a prediction model says, my forecasting says that, okay, this area is expected to have the higher traffic. So I might direct my drivers who are sitting here or here or here, the ideal places, to the places where it is expected to have more traffic. You can always move towards those areas which is expected to have the higher traffic. Again, a data-backed decision. So my prediction model is working in the background, giving you a fair idea that yes, I am forecasted to have more traffic in a particular region. So I can obviously better optimize my drivers accordingly so that I can cater the expected high demand. Again, an interesting Uber insight. But now we're going to talk about one of the very interesting platforms which Uber has developed, Michelangelo. So this Michelangelo, what it does, it's basically the inbuilt platform of Uber, which is providing the scalable, reliable, reproducible, and easy to use automated tools for addressing the problem statements or addressing the data related problems on Uber. And it does 6-step workflow. It manages the data, it trains the model, it evaluates the model, it deploys the model, it makes the prediction, and also with this, it monitors my predictions on a day-to-day basis. So Michelangelo is an inbuilt in-house platform of Uber, and that is a platform where it is able to cater, it is able to provide the needed scalable, reliable, easy to use and automated functionalities on the platform, solving the data analysis problems in 6 different workflow steps: managing my data, training my models, evaluating of my models, deployment of my models, making the predictions, and also at the end, monitoring of my predictions. So again, it's pretty much the similar life cycle. So we talk about this as the life cycle of data problem, ML problem. So we do have the data always, and once we have the data, then we talk about the management. So yes, that is where the databases come into picture. The databases, the data lake, the workflows, the procedures, PL SQL, that is where management of my data comes into picture, database management. We talk about training the models, that's where ML or deep learning comes into picture. Evaluating the models, multiple strategies for different problem statements. We're going to evaluate which is the better model. Deployment, again, it is very subjective. We talk about microservices, we talk about Dockers, talk about some APIs as well. So different companies have different stacks. Michelangelo also uses a Docker mechanism for deployment of my model, making the predictions, monitor of my predictions, everything which pretty much being taken care by the platform inbuilt. So what it does, it enables the internal teams to seamlessly build, deploy, and operate the ML solutions at Uber scale. So it is happily enabling the internal teams to build, deploy, and operate my ML solutions at the scale which we are talking about. Yes, Raj. So I'll give you a source also, so you can find out this on the direct Uber platform also. So they have their inbuilt platform which cater the entire life cycle of my ML problem statement. And it is designed to cover the end-to-end ML workflow, which involves the management of my data, training, evaluation, deployment, making the predictions, and also the monitoring process. And the system also supports the traditional ML models, which includes my time series as well as my deep learning methods as well. And that is where they have the entire ecosystem prepared in the backend, which handles all the problem statement which we were discussing about. All these problem statements can pretty much be handled in Uber on the platform Michelangelo, where it caters and it provides the ecosystem for the internal team to build, deploy, and operate my ML problems from end to end. So at last, I've taken it from their core Uber website. So this is the model architecture which they are trying to look at. You'll find it on the Uber native website as well. So now what it does, it tries to, I think it is going out of my boundary. Just a minute, I think I need to check this. Just a minute, I need to reduce the size of it, I guess. Okay. Fine. So that's pretty much what do we have here. So let's try to understand what happens in the different parts here. So in this case, now let's see, my first phase, I'm talking about getting of my data. Then we talk about training of my data, evaluation, and then the deploy, predict, and monitor. So from the database perspective, we have a data lake, the entry point, where the respective different data source coming into picture. And we talk about the data preparation job, where we have the Spark and the SQL procedures. which is eventually storing the data here, the prepared data, the Hive feature store, which is internally connected with the stream engine of my Cassandra feature store. And what it does for the offline process, we talk about the training algorithm. So whatever algorithm inbuilt, the batch training job. So the respective jobs, the respective data points which I have here, based on this, the respective training algorithm, the batch training process, it is training the data points which are available for a respective business outcome. And that is getting stored in the output here, the model repository, the Cassandra model repository, which here in the offline process, till here I have my data part, so where I'm trying to still get the data. So this is for the offline method, so where the stored database is having the data prepared. And on the live process, when I talk about the live streaming, the Kafka system is streaming my data into my Cassandra feature store on the live front. And the training is obviously an offline process. So I have the batch training process, respective training algorithm for the training. And the evaluation here, I have the Cassandra model. So I have the model repository where the respective model information is getting stored, and we're going to look out which one is a better model in terms of model performance. And then the case of deployment, prediction, and monitoring comes into picture. So yes, in the real-time part, what we look at, so we have the training done. So we have a trained model here, the deployment architecture. And the training model, what it does, it gets the data real-time from this feed, and the real-time predict service, it gives the feature, and whatever features I have, we're going to provide a client service. This client service gives the feature to this trained model and gets the output, whatever the trained model has done. And for this trained model, yes, so we have the batch predict job on the Spark, which is giving us the real-time predictions getting stored on Hive or Kafka. And then it is also connected to my performance monitoring job, which is saving the metrics, like whatever evaluation strategies I have for the respective business problem on the monitoring system, which is there in Michelangelo for monitoring purpose. So real-time monitoring again happening on my data. So all of these data pointers, we talk about the basic core structure, how Michelangelo works internally. So going a bit detailed here. So 4 phases broadly: getting the data, training and evaluation. At the end, we talk about deployment and predictions, right? So that's how overall life cycle of a data science problem looks like in Michelangelo. Cool. So this is what, guys, I technically wanted to cover in today's discussion. So with this, I have covered the pointers. Any questions, I'm more than happy to take that in. So you can pretty much ask your questions if we have. But I hope that made sense to you, right? So this is what and how Uber solves a business problem on data with the help of data in data science. And we talked about multiple problem statements. We talked about a different core structure as well. So what model would be the best suited is also chosen by Michelangelo. To be honest, I am not 100% sure of. So because that is something which is internal to Uber. So we will never get to know that unless and until we are part of that. But I believe what it does, because it gives you a repository of different problem statements. So it does compare. So there might be an algorithm which takes care of a pool of different logics and algos. And then at the end, it tries to give you a platform or a database which has the usage of different algorithms, and then different metrics which is coming from different algorithms. So might give you an option to choose from one of that. And maybe it might be an automated process as well, which might choose the maximum performance one. But I cannot guarantee that solution. I cannot give you a 100% sure answer for that, because that is something which is internal to Uber. So we can only get to know things which is available on the public blogs or forums for that. So that is not where I mentioned. But still, I think that should not be a major challenge at the end of the day. So it's not about choosing which algorithm, to be honest. So it's about finding the best result, right? So how does it matter? So at the end of the day, if I'm getting the best performance, so I don't think that is anyway a very crucial problem statement to look out for, like which model is the best. So that is anyway in a business that makes little sense, to be honest. So we're still focused towards getting the best performance. For online phase, how the system evaluate model, does it need some offline platform? So for the online phase, what it does ultimately, the predictions are coming up, right? So we always talk about a Kafka system, which is getting a stream bashed for different predictions for a live data. And ultimately there's a monitoring system as well. So monitoring system, it does track the real-time performances. Like for example, I predict for something today, and yes, for that, suppose I say after 4 hours, that is going to be my traffic, right? And I know the real data after 4 hours also. So there is a metric, predicted data and the actual data as well, after anyway n amount of time. And that is what metric we talk about. And this metric is anyway getting stored in my relatable database where I have the monitoring system. So that monitoring system always keeps on comparing my predicted data and the actual data and keep on giving you the real-time performance of your model, which is running on the system. And then in the monitoring phase, we always look at a threshold. So if suppose I delivered an offline method at say 90% of model performance, and after a certain point of time, it drops down to 70%. So that's where we have a threshold that yes, we might need certain bit of improvement there. So that's how it tracks. But if that's the case, then it's really good way of reducing operational cost. Yes, absolutely, I agree with this, Vertika, and that is where the automated process of Michelangelo works, and it tries to optimize the different methods and tries to give you the business objective. If the business objective is to have the best model performance, it tries to choose the algorithm likewise. What if the system wants to have the RCA as well, the root cause analysis? So I might not go for the black box techniques, right? So obviously, depending on the business objective, it does try to find out the best algorithm. Cool, guys? Any further questions? Great. So with this, guys, thank you so much. It was really a pleasure, as always, talking to everybody here. So with this, we have completed our another use case on machine learning from Uber. And now in the next class, we will be talking about a new topic, and we're going to meet a day after from today. So, and then we're going to take another topic. We'll be continuing our discussion. Cool, guys. Thank you so much. See you day after, and then we're going to start with a new topic. Thank you so much. Bye-bye. Have a good evening.